Hello students, the first problem in exercise 1.2 is represent these numbers on the number line. Numbers are given, so first we have to represent 7 by 4 on number line. For that, first draw the number line. You can see that is a positive number, so draw or plot points on the right side of 0. Okay, 0 can be written as 0 by 4 because the denominator is 4. Okay, then next number will be 1 by 4 and the other numbers are 2 by 4, 3 by 4, 4 by 4, that is same as 1, then 5 by 4, 6 by 4 and 7 by 4. So you can see 7 by 4, then draw a dot at that point. Okay, so this is how we represent points. Okay, next number is negative 5 by 6, so that is a negative number. So you have to plot the points on the left side of 0. Okay, so plot 0. 0 can be written as 0 by 6 because the denominator is 6. Okay, then plot another points. Then you can see the denominator is same, numerator will be varying. Okay, next one is negative 1 by 6, then negative 2 by 6, negative 3 by 6, negative 4 by 6, negative 5 by 6 and negative 6 by 6, that is same as negative 1. So you can see negative 5 by 6 there. Okay, so this is the method. Then we can move on to the second problem. In this problem also we have to represent the given numbers on number line. You can see the denominators are, the denominator is 11 and these are negative numbers. Okay, so draw the number line and these numbers should be on the left side of 0. So draw 0, plot 0 at there, 0 there. Okay, then next point 0 can be written as 0 by 11, then next number will be negative 1 by 11, then negative 2 by 11, negative 2 by 11 is a required point, so draw a dot, then negative 3 by 11, negative 4 by 11, negative 5 by 11, again that is required point, draw a dot, then negative at a negative distance you can plot negative 6 by 11, negative 7 by 11, negative 8 by 11, then negative 9 by 11. At 9 by 11 also, negative 9 by 11 also you have to draw a dot. Then next numbers are, if you need you can plot two more numbers. Okay, so negative 10 by 11, then negative 11 by 11, that is same as negative 1. Okay, so this is how we represent the given rational numbers on number line. We can just look at the denominator and thereby we can plot it. The third problem is write 5 rational numbers which are smaller than 2. Okay, so we can first rewrite 2 in any form. We can write 2 as 12 by 6, 14 by 7. So here I am writing 2 as 12 by 6. Then you can see there are so many numbers which are less than 12 by 6. Okay, the denominator can be written as same, you can just change the numerator. Okay, so I am taking the required rational numbers as 1 by 6, 2 by 6, 3 by 6, 4 by 6 and 5 by 6. You can take any number which is less than 12 with denominator 6. Okay, that will be the required numbers. Then we can move on to next one. Find 10 rational numbers between negative 2 by 5 and 1 by 2. Here you can see the denominators are different, so you can use that LCM method. Okay, so LCM of 5 and 2 will be, that is just multiplication, 5 times 2 which is equal to 10. Okay, so here you have to rewrite the given numbers into the numbers with the denominator 10. So multiply negative 2 by 5 by 2, you will obtain negative 4 by 10, then multiply 1 by 2 by, multiply the numerator and denominator by 5, you will obtain that is 5 by 10. Okay, so you can see there are so many numbers in between these. Okay, we have to list 10 of them. So negative 3 by 10, negative 2 by 10, negative 1 by 10, negative, that is 0 by 10 is same as 0. So then next one is 1 by 10, 2 by 10, 3 by 10 and 4 by 10. But you can see here we don't have 10 rational numbers, we have only 8 rational numbers. Okay, so this method will not work, so we can just change the denominator. Okay, so I am going to take another multiple of 5 and 2. Okay, so we can take that as, say 20, we can take that as 20. Okay, so negative 2 by 5 can be written as, multiply the numerator and denominator by that is same as negative 2 by 5, multiply that by 4. Okay, so we will obtain the denominator as 20. Okay, so that is same as negative 8 by 20. Then you can write 1 by 2 as, in order to obtain the denominator 20, you have to multiply by 10. Okay, multiply the numerator and denominator by 10, you will obtain 10 by 20. So you can see the rational numbers that lies in between these two are negative 7 by 20, negative 8 by, negative 6 by 20, negative 5 by 20, negative 4 by 20, negative 3 by 20, then negative 2 by 20, negative 1 by 20. We have to list only 10. Okay, then 0 by 20 is same as 0. Okay, so you can just write 0. Then next number is 1 by 20 and 2 by 20. So you can see these are 10 rational numbers. So you can take denominator as any multiple of 5 and 2. Okay, that will work. Now we can move on to the fifth problem. Find 5 rational numbers between the given rational numbers. So the first rational numbers are 2 by 3 and 4 by 5. So I am going to take any common multiple of 3 and 5, say 15. So multiply 2 by 3 by 5, you will obtain 10 by 15. Similarly, multiply 4 by 5 by 3, then only you will obtain the denominator as 15. Okay, so multiply the numerator and denominator by 3, you will obtain 12 by 15. So you can see 10 by 15 and 12 by 15. So there will be only one rational number, 11 by 15 will be there. So you have to list 5. This method will not work. Okay, so you have to change that common multiple. So I am going to multiply 2 by 3 by 15. Okay, so that the denominator becomes 45. So 2 times 15 is 30. That becomes 30 by 45. Then in order to obtain the denominator as 45, multiply 4 by 5 by 9. So you will obtain 4 times 9 is 36. So 36 by 45. Now you can see there will be exactly 5 rational numbers between these 30 by 45 and 36 by 45. Therefore the required rational numbers are 31 by 45, then 32 by 45, 33 by 45. You have to write the denominator same, but you have to change the numerator. Then next number is 34 by 45, then last number is 35 by 45. So these are the required 5 rational numbers. So you can take any common multiple of 3 and 5 to do this problem. Okay, and then we can move on to the next set. Here also we have to find 5 rational numbers that lies in between negative 3 by 2 and 5 by 3. So denominators are different, so you can take any common multiple of 2 and 3. I am going to multiply negative 3 by 2 by 3 so that the denominator becomes 6. So we will obtain negative 9 by 6, then 5 by 3. In order to obtain 6 as the denominator, multiply by 2, you will obtain that is 10 by 6. So there will be enough numbers, so you can see negative, the required numbers are, you can write, then therefore the numbers are negative 8 by 6, comma, negative 7 by 6, negative 6 by 6, that is same as negative 1. Actually that is negative 1, okay. Then negative 5 by 6, negative 4 by 6. Okay, so these are the required rational numbers. You can take any 5 of them. Okay, then we can move on to the third set of problems. That is continuation of this problem. So in that problem also you need to find 5 rational numbers that lies in between, you can see 1 by 4 and 1 by 2. Okay, so we need to find 5 rational numbers. So as we discussed in the last video, we have to take a large multiple, then only you will obtain 5 rational numbers. So I am going to multiply 1 by 4 by 12. Okay, so multiply the numerator and denominator by, say, we can first try 6. Okay, so you will obtain that as 6 by 24. Then in order to obtain the denominator as 24, multiply 1 by 2 by 12. Okay, multiply the numerator and denominator by 12, you will obtain that as 1 times 12 by 2 times 12, which is equal to 1 times 12 is same as 12 by 2 times 12 is 24. Okay, so we can see there will be, you will obtain 5 rational numbers. So we can take the rational numbers as 7 by 24, 8 by 24, 9 by 24, then 10 by 24 and 11 by 24. So you can take any other multiple, okay, any other common multiple. You will also obtain rational numbers. So infinitely many rational numbers are there, so you can take any common multiple as the denominator. Okay, then next problem is write 5 rational numbers greater than -2. Okay, so here you can rewrite -2 as similarly as we did in second problem. Okay, so -12 by 6. So the numbers greater than -2 will be -11 by 6, -10 by 6, -9 by 6. We have to write only 5 of them. Then -8 by 6 and -7 by 6. Actually, you can write -2 as -12 by 6, -14 by 7, -10 by 5. You can write in any other way. Okay, there are infinitely many rational numbers, so you will obtain that. Okay, then we can move on to the last problem. Find 10 rational numbers between 3 by 5 and 3 by 4. So we have to find out a common multiple of 3 and 5. So I am going to multiply 3 by 5 by, say, you can take any common multiple. So I am going to multiply this by 4. Okay, so that the denominator becomes 20. So numerator is 12 and denominator is 20. So 3 by 5 becomes 12 by 20. In order to obtain the denominator is 20, you have to multiply 3 by 4 by 5. Okay, multiply the numerator and denominator, so that is equal to 15 by 20. Here you can see in between 12 and 15 there will be only 3 rational numbers, so this will not work. We need to find 10. Okay, so I am going to multiply by 2. You will obtain that as 24 by 40, and 3 by 4 is the denominator is same, so multiply by 2. You will obtain that as 30 by 40. Then also you can see only 6 rational numbers are there, but we need to find 10. Okay, similarly multiply that 24 by 40 by 2 and 30 by 40 by 2. Okay, so you will obtain that as 24 times 2 is 48 by 40 times 2 is 80, then 30 times 2 is 6, so that is equal to 60 by 80. Okay, so there will be enough numbers, there will be more than exactly 10 numbers, so the required numbers. Therefore the numbers are, you can write 49 by 80. You need to just change the numerator. Okay, then 50 by 80, 51 by 80, 52 by 80, 53 by 80, 54 by 80, then 55 by 80. Yeah, actually one number is missing, so you can take any 5. Okay, any 10. Then 56 by 80, 57 by 80, 58 by 80 and 59 by 80. Okay, you can take any 10 numbers that lies in between 40 by 80 and 60 by 80. Okay, so we have completed chapter 1. Okay, if you have any doubt, you can mention it in the comment section. Thank you.